Hello, everyone, and welcome to the newest Alot webinar. And we're going to talk about how trends in NFV and in the telecom industry in general, and specifically in the context of trends that we see in DDoS around the world, how these kind of come together and converge, NFV, 5G, technology trends, to make it possible for a more powerful and flexible DDoS security solution for communication service provider networks, but also for them to be able to offer to their enterprise customers. My name is Michael Schachter. I'm a product marketing director at Alot, and today's webinar, Ariel Cohen and Elia Haverman from our product management, they'll dive down into the NFV and DDoS aspects that we want to address. And then we're going to share an online demo to show, to give you a good idea of what that means, of how DDoS can be helped by an NFV architecture. And enjoy the webinar.
Thank you, Michael. Hello, everyone. My name is Ariel Cohen, and I'm a senior product manager at Alot in charge of NFV. And I would like to give a very short brief of the NFV so we can actually compact everything into this presentation, the NFV segment, the DDoS, the match between the two, and the live demo. But before we go into details, let's talk just a bit about the state of the industry at 30,000 feet. The NFV industry is forecasted to be immense in size. There are market researchers that even predict this kind of market will reach a value of about $70 billion by 2024. And really, regardless if it's 60 or 80, it's a very significant amount that should be reckoned. In practice, we see major tier one heavily engaged in NFV, in their journey towards NFV. Some are leading in this domain with AT&T, for example, who have already virtualized 65% of their network. Verizon, as far as I know, have reached 60%, which does represent a significant amount of the network being transitioned from legacy-based services to NFV. Another thing that is happening is that network expansion today is relying heavily on COTS-based hardware, which is wonderful for NFV because this is an underlying infrastructure that is used for NFV networks and NFV expansion. And on top of all of this, we have the 5G coming in, which is a huge disruptor. It's actually changing the way we do things in a very radical way. It's changing the architecture. It's really based on NFV and cloud-native technologies, which I will talk about in a moment. And again, in this domain, we see many operators already on their way, heavily engaged in planning, in deploying several sites, and in having their future plans evolving around this technology. So to sum up all of this slide in a nutshell, we say that the major operators are heavily engaged in this technology, mainly due to the promise it gives and due to the agility and the OpEx reduction. So Michael, over to you for this.
Yeah, okay. So as I said, I will be interrupting every now and then with some questions because we do want to understand the audience as well. So Ariel just gave a very high overview of what the industry is looking like, and we're curious for your organizations, what is the single most reason or highest ranking reason for moving to NFV to the degree that you're moving? Is it to save, upfront CapEx costs by not having to buy as much hardware potentially? Is it to save OpEx, and that speaks to the agility that Ariel mentioned? Maybe it's to be able to bring services to market more quickly for competitive advantages, but not necessarily because of the lower costs associated. Or perhaps it is all of the above. All of those speak to you equally. So we'd appreciate if you can select your answers. Okay, so service agility, but even more so all of the above. So that's an interesting breakdown. OpEx and CapEx fairly similar. but the biggest one is all of the above. Okay, great. Thanks a lot. And back to NFV. No, another question. So we saw why you want to do NFV, and the question is, when are you doing it? Is it already underway in your network? Is it something that's only going to start later this year, or not even start until next year? Or are you an organization that has decided that you don't need NFV? COTS is fine, proprietary hardware is fine, you're managing just fine, and you're not so concerned about transitioning to NFV yet. And let's take a look at the responses. So it's underway in the majority, and others, the next biggest is next year, and not even bothering with it, not thinking it's necessary, which is certainly a legitimate position, is at the bottom. Okay, great, very interesting. Thank you very much. And now back to Ariel.
Great. So we spoke about the industry at a high level. I would like to make a distinction because on the journey to NFV, you move through several stages. The first one is actually performing your network expansion on appliance, which means you are taking the good old COTS hardware. You are not using proprietary hardware anymore, as in the legacy world, but you are using physical appliances and using these to run your network-based services. This is represented in the column on the left, which is titled Appliance. And that's an extremely valid way of going about expanding your network. Another way is referred to as virtualization, where you're still taking the COTS-based servers, however, not running your network-based services directly on the COTS. There is a kind of a shim layer called a hypervisor, which provides the virtualization, in which every network service, every network element is virtualized, offered as software only, and running as a virtual machine on top of this hypervisor, which resides on the server. When you're going in that direction, your network actually becomes virtualized. You're not relying on the direct connection between the software and the hardware, and you're free to spin up new services, remove existing ones. Everything becomes more software-based, but still not cloud-based, not NFV-based. The next step is on the right column, referred to as the NFV and telco cloud, where you are actually building your entire network on cloud-based services. A good example for this would be a tier 1 operator expanding his network on a private cloud, for example, operated by OpenStack or VMware. And on top of this cloud-based infrastructure, you are running your entire network as one holistic approach of virtualizing your network. You're not confined to specific servers anymore. You are getting the entire cloud as a resource. Now, taking this thought of cloud, we are going to move to telco cloud and cloud native. But just before that, Michael, I saw you have another poll question. So maybe over to you for a moment.
Yeah, I'm going to bother you one more time, Ariel, and then let you finish up the NFV introduction. So given what Ariel said about the different kinds of architectures over which you might be running, and we'll see in a minute how Allot has implemented our solutions, what kind of orchestration are you using in your already beginning to be deployed NFV networks? And this is a pretty technical question, so we put in a don't know answer in case you're not in those details. But do you not have orchestration, which is one option? Are you using the VNFM S or G variants, or you're using service orchestrators, or you just are not sure how it's being done? Okay, let's take a look at that. Okay, fair enough. An interesting distribution. And thank you for your input, and I will let Ariel finish up with the NFV introduction.
Okay, thank you. So this picture actually illustrates an NFV-based network where you have the underlying infrastructure, the NFVI, which is operated by a cloud operating system, be it, for example, OpenStack or VMware. And on top of that, all the services or the network-based services are running, which are represented here in the blue boxes, which are titled a lot. When you're running on a cloud, you want to benefit from your cloud and really spin up new services when you need them, expand them, reduce them, terminate them, however you need. And this sort of actions are referred to as life cycle management, which are represented by the circle on the right. From the moment you create the service and bring it up, all the way to monitoring, expanding, reducing, etc., up to termination. All of this is done by an entity called an orchestrator, and this is why we had the question also before. There are many types of orchestrators, but essentially the agility, the saving of OpEx due to the automation and due to the agility is given by using a service orchestrator, which looks at the entire network end-to-end and spins up full services end-to-end. Now, we did speak about appliances, we spoke about virtualization, and we just spoke about NFV. But this is really not the last step. It's just one more step on the way forward, because today, especially in relation to 5G technologies, the world is evolving, and the NFV thinking is evolving to become more like telco cloud and network automation thinking, where the cloud turns from a private cloud to a, let's say, native cloud. And what this means is that when you migrate to, let's say, cloud native services or cloud native thinking, you're not just transitioning your networking services to the cloud-based network, you're transitioning all of your services to the cloud-based network. And all the thinking from the bottom up is really to reap the benefits of using a cloud-based infrastructure. Now, let's look a bit about the technologies around this. First of all, when moving to the cloud, there is a heavy emphasis on containerization. In NFV, we had an entity called a virtual machine. In cloud-native technology, we are using containers. They are much more leaner, faster to spin up, standardized to work on any type of infrastructure, and really designed for microservices, which means that your entire application is much more agile. Also, being a cloud-native technology, you can reap a lot of benefits that are given from the cloud itself, and you do not need to develop them by yourself in order to gain these benefits. Some examples could be limitless compute power from your network, ease of deployment and scalability. You get all of your deployment tools and deployment processes given by cloud-based orchestrators. All the issues of high availability and health checks and logs and monitoring and intercommunication is all standardized, and you actually use the native cloud services in order to spin up your services and manage them. And all of this, if I was talking about cloud orchestration and cloud native platforms, should be managed by some cluster management system. There are many cluster management systems, but the main one, the predominant one, which I'm sure you have heard the name, is Kubernetes. And this is the leading platform as of today. And it really manages all of the lifecycle management of the entities on the cloud. It is intent-based driven, which means you do not need to tell it what to do. You just need to tell it where you want to go to. It's really open source, future-proof, and integrates with just about any cloud out there. So hopefully this brief was expansive enough to give some sense of what we mean by NFV technology and cloud-native technology. And with your permission, Elia, I'll hand over the session to you to talk about our DDoS solution.
Thank you, Ariel. That was really, really interesting. All this cloud-native stuff is going to come up, and it's going to ease, deployment of new services in the network, and I'm really looking forward to it. Now I want to talk about DDoS. So I guess that most of you suffered from a DDoS attack, or at least know exactly what it is. But still, I want to, spend a little moment on the question: what is DDoS? And the abbreviation stands for Distributed Denial of Service Attack, and it means that you have some kind of attack that is not aiming on taking over the target, but it's aiming on taking the target out of service. And there's different ways to do that. And you can do that by exploiting a vulnerability on the device that lets it crash. You can do it by exploiting a way to exhaust resources on the target itself. But the most common DDoS out there is a DDoS that exhausts networking resources of the target, meaning by just flooding the network with too much traffic, the target will be out of service. And this can happen inbound. It means that hosts from the internet are going to attack one of your hosts in your own network, which is a very common way of DDoS. But outbound DDoS is also a real threat, especially if you are a CSP with tons and tons of users on your network. So your own users can become, the attacking sources, and will have impact on your own network as well as the target in the internet that they are attacking. And what's so interesting about these volumetric DDoS attacks that really try to overwhelm the network's capacity is that they not only harm the target itself, they actually have a lot of collateral damage. And DDoS attacks are real. So in case you didn't experience one of them, it means that you are in a very, very rare situation. And this is like a screenshot that we took from digitalattackmap.com. It's a website I recommend to go to. And it shows you in real time all the DDoSes that are happening on this planet. And as you can see from this picture, there's not a single spot on the whole world which is free of DDoS. They happen in all continents, in all countries, and in all different scales and sizes, and at any time of day. Talking about the trends, DDoS has evolved over time. The first DDoSes ever launched were launched by a tool called LOIC, which means Low Orbit Ion Cannon, which was like a little Windows tool that anybody could install on their Windows machine and then manually engage into a DDoS attack. And this tool was downloaded by non-hacker people and that were guided by hackers in order to do something like what we call hacktivism, meaning that they have a target they want to take down and they join forces in order to do DDoS. And that was like the innocent times of DDoS. And today, DDoS is a business, and it's done in order to harm your competition, in order to smoke screen real attacks happening, in order to keep your security personnel busy with the DDoS. It's done for revenge. It's done like on nation scale and to disrupt service and many things more. And what we see is that about 72% of those attacks are those volumetric attacks that we talked about before. And another thing that we're seeing is that we have more and more attacks, but they become shorter in time. And that's a very interesting combination. More attack, shorter in time, means that you have a lot of hit-and-run attacks. Attacks that are meant to keep your resources busy, then you think you're safe, and then the next attack wave comes in, and that's much harder to defend than one long and strong attack. And a fourth thing that is interesting to understand is that the complexity of attacks is increasing. And this is due to a lot of IoT devices out there with very low security that can be weaponized and made into bots and can be instructed by some command and control servers to do very, very sophisticated, very targeted attacks that are built for the target itself and not just some random attack that you would hit on anything. So as I said, that you all must have at least witnessed some DDoS attacks. Let's go to the next poll question. Michael?
The next poll question has to do with your evaluation of how much bandwidth you think that you're losing to DDoS on an ongoing basis. Is it up to 5%, from 5 to 10%, up to 15%, or 20%, or even more? Yesterday, Verizon published their 2020 data breach investigation report. And interestingly, they have found that denial of service attacks spiked significantly during the past year. They now make up 40% of security attacks across the Verizon networks, I guess. And their findings include the fact that volumetric DDoS is the biggest attack vector today. Volumetric ones are also threatening residential subscribers and not just service centers like CSPs or financial institutions or any kind of enterprise. And that, it's here and it's a growing trend, and they're getting bigger and, as pointed out, shorter and harder to stop. So let's take a look at what you all think. This is quite alarming. This means, obviously, that a very significant amount of your investment in network infrastructure is actually going down, the tubes, shall we say. It means that that you really need, 115% or 120% capacity to get the 100% that you wanted to be delivering. So a good DDoS mitigation solution is worth its weight in, percentages of network bandwidth. That's good to hear. I mean, it's bad that it's happening, but it's good that there's a need.
It's good for us, but no, we want DDoS to go away over time, but it won't happen so fast. So we did some research about the impact on quality of experience, and quality of experience is what customers think about the service that they're getting. So it's something that is a little hard to measure, and we built some machine learning algorithms in order to understand, for example, how satisfied users are with the video experience. And we use all of this knowledge in order to do some research. And we also asked our customers, and 84% of CSPs report that the DDoS accounts to 3 to 5% of their traffic. So when you answered 20%, I'm guessing that you are, running smaller networks, because in a smaller network, a big DDoS has a much bigger impact than on a huge network, percentage-wise. Also, what our customers think is that IoT is going to make things worse, and that's something that we totally agree with. As I said before, IoT devices are low in security, available in big masses, always on, always connected, and can be controlled in a botnet and be used as bots in order to attack a target whenever desired. And together with 5G, which is basically built for IoT as well, we're going to have much more bandwidth. So if one user equipment device has about a gigabit of bandwidth upstream, then combining some of these devices will already create a huge attack that we didn't see before. In the past, most connectivity was asymmetric, meaning that private devices would have much more downstream than upstream, and in 5G that's not the case. And DDoS is costing money. It's resources being wasted, it's quality of experience being impacted, and it's also making your customers unhappy, and unhappy customers cost money in different ways. When we're talking about money, how much does it cost? And depending on the attack, we see that one attack can take up to $100,000 of money of revenue from your company. Some even say that it's $1 million per event. And when you break it down to how much it costs per hour, then prices vary between $20,000 and $40,000 an hour. And 52% of enterprises and small, medium businesses have faced DDoS attacks. And for big enterprises, they have cost about $2 million per event. And for small, medium enterprises, it's obviously less, but it's still very, very expensive. And these costs are, missed SLAs, massive call center calls that you have to deal with. Each call costs in a call center about $30. The infrastructure has to recover. If you have a stateful device that crashed because it's overwhelmed, to bring it up takes a long time. And then you have, unhappy customers leaving and going to your competition.
You all have said that it's a widespread phenomenon, and the research that we've conducted, and Cisco and other companies certainly supports that. And so then the question, obviously, is, do you already have a DDoS mitigation solution in place? And the possible answers that we saw are yes, but we only are treating the inbound ones that Elia described as volumetric or other attacks coming into your network, perhaps targeting you or targeting something behind you, or inbound and outbound. That means you're able to see DDoS traffic in either direction. So if you're supporting, I don't know, mobile-equipped vending machines or electric grid meters that are, connected to the network, and they become weaponized, will you see that coming through your network and heading outward, only outward, or no, you don't have a solution yet? And if that's your answer, please get in touch. Let's take a look at the answers. Okay, so overwhelmingly the lead is yes, although no is also in a pretty high spot there. So as I said, we'd be happy to talk to you about a solution if it's a CSP or enterprise. Nobody is only looking at outbound, and that's not surprising because it's sort of a newer take on things. And 20%, 21% do have inbound and outbound solutions in place. So there's a problem out there, and solutions are needed. Let's continue the dialogue.
When we talk about 5G, there's something new coming to place. And 5G, one of the main advantages of 5G over 4G is latency. Not just more bandwidth, but also latency. And this latency is achieved by using MEC, mobile edge computing. So that whenever you have any kind of application talking to the internet, the traffic is not transported back to the central office, but is actually, sent to the internet as close to the end user device as possible through the MEC. And in the mobile edge computing, you also have, integration with cloud operators that run their clouds and their cloud-native applications in the mobile edge computing platforms of the CSPs in order to allow low-latency applications like autonomous driving of cars and so on. So the MEC is very vulnerable because it's built to support what it needs to support, but not more. So if you have a DDoS attack reaching the MEC, then you need to be ready to defend against it. When in 4G and in other infrastructures, all of your traffic would come through the central office, it would be very simple to just defend the attacks that are coming in through the central office in one DDoS solution, and then you're fine. But when we talk about 5G, then you have to become, much more network-wide when it comes to your DDoS protection. And another thing that is new is outbound. And as I said before, with 5G, the end-user devices have much, much more capacity. They have up to gigabits of bandwidth at their disposal to abuse and send out attacks. And you have a lot of IoT devices that are always on and always waiting to be able to attack. And especially those low-latency IoT devices. And the attacks that are coming from those devices can actually create a lot of collateral damage on the MEC itself and obviously also on the central office. So when talking about outbound DDoS, the prevention has to happen where the attack happens, so in the MEC. And this is what we're doing. you can deploy our NFV-based solution anywhere in your network, in the central office, in all of the MECs, with hundreds and hundreds of MECs throughout the country, and they all centralized in a centralized controller so that we can see attacks coming from everywhere to everywhere and have mitigation plans available for every part of your network, no matter where it comes from and where it happens. As I said, this is true for inbound that can come to the MEC or to the central office, and for outbound that will hurt your MEC and also the central office. But how to do that? Most DDoS solutions out there, especially when it comes to big scale, are based on information they get from the routers. And the information they get is called NetFlow. It's an open standard, or SFlow. And they collect those statistics, and based on those statistics, a controller understands that there is an attack, and when the attack happens, a reroute of the attack traffic is happening, and it's sent to a scrubbing center. And these scrubbing centers are operated by the operators, by the CSPs themselves normally. Unless it's an enterprise, then the scrubbing center can be sitting somewhere in the cloud. And the traffic has to be diverted, cleaned, and sent back. And this has multiple issues. It's slow because you have to react to those samples with a lot of delay. Then the samples are normally aggregated, meaning you only see 1/1000th or 1/10,000th of the traffic that's actually going through the system, so you are missing all the small-sized attacks. And the reroute itself can take up to minutes, depending on what kind of setup you have. And if you have short hit-and-run attacks, then the reroute will take too long for a scrubbing center to actually do it. And the other problem is, like we saw before, in the 5G environment, rerouting traffic won't help you. You will still have all the attack traffic creating collateral damage in your mobile edge computing and in your central office before it even reaches your scrubbing center, especially when it comes to outgoing attacks. So you have to go inline. There are inline solutions out there, but most of them are for enterprise use. So like for small scale, up to a gigabit or maybe 5 gigabits, okay? And the Allot solution is built with terabit scale in mind, meaning that you can run your devices, your virtual or physical appliances that Ariel presented to us earlier, and you can actually mix and match them as you like. For devices that do terabit. And our biggest installations actually do that. So they do terabit inline. And when you're inline, you have fast mitigation. You can do it in seconds instead of in minutes. It's very accurate because it sees all traffic and not just the traffic statistics that are coming from some third-party routers. The centralized controller allows you to work in an environment where user traffic and internet traffic switches around, where it's asymmetric traffic that comes in through one pop and leaves through another one, or a user that's roaming from one radio to another, and all this doesn't matter to detect and mitigate an attack if you have a centralized controller. Inbound and outbound attacks have to be mitigated, and what we see is that our competition, doesn't really treat outbound attacks with the seriousity that it actually needs. They don't take it serious enough. So what they normally do is they allow you to configure some fixed thresholds, and if those thresholds are met, then we understand it's an attack. But in Allot, we treat inbound and outbound the same. So we have the same quality of detection, same quality of mitigation, no matter from which direction it comes. And that's very important, okay? Then zero-day. We spoke before about the fact that the attacks become more and more complex because of the IoT world, because of the business behind it as well, so the motivation to create targeted attacks. And so it happens more and more that an attack is a zero-day attack, meaning that it has never been seen before. If it has never been seen before, then a threat intelligence system collecting information about attacks happening somewhere else will not help you. So that's the reason we don't need threat intelligence. We just treat every attack like a 0-day, okay? So the way we do it is that we take actual attack traffic, and from that attack traffic, we create a mitigation plan. And if it's inline, then it's always on. You don't need to reroute. It works immediately, and it can use also, the built-in DPI capabilities to assure QoE even before the attack was detected, like doing quality of service for vital protocols like DNS protocols and stuff like this. And last but not least, and this is what we get as a feedback from our customers, which is like the most important thing for them, it works automatic, no supervision. They don't need a NOC watching the DDoS solution all the time. They come in the morning to the offices and then get a report about all the DDoSes that happened in the night and are happy that they all have been mitigated. So how does it work? From the inline sensors that are distributed throughout your network, in the MAC, in the POPs, in the central office, we get statistics. And from these statistics, we learn the behavior of the network. And we call it a baseline. We create a baseline of traffic where we can expect what's coming up next and how the traffic should look like. And when this changes, we detect an attack. And when we detect an attack, we analyze it and we see where it comes from, what kind of signal is it using, what kind of traffic is creating the attack. And in order to do that, we use traffic captures that we receive from the sensors and analyze in real time. And when we did that, we create a pattern. And the pattern uses, obviously, all information in the IPv4 and IPv6 header, but also payload, meaning if you have a reoccurring pattern that is in the payload, we will use it for filtering. And that allows you to put very, very aggressive mitigation plans that actually filters every packet that matches the pattern, and you don't need to rate limit or something in order to avoid over mitigation. And with that activated policy pushed to the sensors, your network is safe again. And how does it work? That's a little technical. If you're not interested in the technical details, you can go and get a coffee. But everybody who loves the technical details, this is how we work. When we decide whether something is an attack or not, we use the baseline. We compare the signals that we receive from our sensors to the baseline, and then we can detect a jump. But sometimes regular traffic looks like a jump. So let's say one of your customers launches a new product, launches a new service, and all the customers come and tune into that service at that specific time, and then at this specific time it looks like a DDoS, it looks like a jump in the traffic. So the way we avoid that is that we look at a complementary signal. And in this example, we're using the example that is the most easy to understand, which means we compare the SYN in signal with a FIN out. So who knows TCP will understand that every TCP connection, every valid TCP connection begins with a SYN in that's coming into your network and will end with a FIN out, meaning every TCP connection has a beginning and an end. As TCP connections can, be alive for seconds or be alive for hours, the ratio between SYN in and FIN out is not always 1, but it's always close to 1. But when there is a SYN attack, then this changes. And this is what you see on the right side of the screen. We have a SYN flood coming in. The flood itself is smaller than the traffic jump on the right, okay? But the imbalance between SYN in and FIN out will create a significant understanding that this is an attack. And because we do that, we can rule out traffic jumps from attacks and can even mitigate small attacks that might be, otherwise under the radar. It's called the Slashdot effect. So for those people that are in the business a little bit longer, that remember the website Slashdot, when you were mentioned on Slashdot, you got a lot of traffic to your website coming, which killed a lot of servers in the past. It's not happening anymore, but the name sticks. So the Slashdot effect is something that we do not want to mitigate because that's desired traffic. Michael. Now is the time we want to try the demo.
Yeah. Okay, so we're going to go to a demo. LEI is going to use a feature on this platform that is supposed to share the screen so that you can see the live demo from another window on his computer. We've had occasionally problems with the platform. If it doesn't work out, we will share a Zoom link and switch over to Zoom. But let's try to share the screen now.
Michael, do you have a poll question?
I'm sitting here on the demo screen. Okay, before we go into the demo, I see your point. We do have a poll question while we're readying the demo. So we talked a lot about the new technologies and the new impact that they might have on DDoS. Your own expectation about 5G and DDoS, do you think that it will get worse? Do you think that it will get less problematic? Do you think that the 5G network will somehow protect from DDoS? Or do you think that it will just continue as it was? We have those options for your sort of opportunity to prophesize here how 5G will impact DDoS. Okay, let's take a look. And I think either we were persuasive or it just makes clear sense and you already felt that already. It does seem like there's a problem heading our way, right? It's the bigger the pipe, the bigger the flood. It's the, the massive IoT that both Ariel and Elia referenced. And it's the distributed architecture with many more points of access, which are also potential points of problem. So that is what we see as well, and that's why we're moving to a virtualized approach to this solution. So hopefully you will very soon be able to see the screen of the demo. I see it coming up now on my window. So hopefully you all see it as well. And go back to you to describe the demo. Thanks, Elia.
Thank you. So I'll just give a brief of the demo, and then we'll have Elia demoing. So really what we are doing now is combining both worlds, the NFV and the DDoS, and this is the use case we are going to show, which is actually a real use case. So the idea is that we want to protect the network from DDoS attacks. We want to be able to mitigate huge attacks and do it fast, which refers to what Elia spoke about, that we are inline, we don't sample the traffic, we immediately identify it and mitigate. However, our life is not that simple. All of this has to be done on an NFV-based infrastructure, and moving to 5G networks, it needs to be on a cloud-native-based network. And this is really the, let's say, the cherry on the ice cream or on the cake, is that we are actually defending the network from DDoS attacks, but we do not need to spin up from day one all the DDoS defense machines that Allot can deploy inline. We just deploy at the central sites, at the peering points, and we have the capacity and the ability to detect when an attack has exceeded the amount of traffic that the existing devices can handle, and we spin up new devices automatically as a reaction to this attack. So we not only detect an attack is happening, we actually increase our size to accommodate for it. The other side is once the attack has stopped and we detect that the attack has stopped, we do the other thing. We actually spin down. We remove the additional DDoS defense machines that we added previously in order to free up network resources because we don't need them anymore, and because we are really agile in the sense that we can mitigate an attack when it's happening, but we don't need to deploy all the resources from day one. On top of all of that, of course, we provide clear indication that an attack has happened, that it is happening at this moment, or it has stopped. And this is really what we are going to show in the demo. So, Elia, over to you.
Yes, thank you very much, Ariel. What's important to understand is that not only do we support, for example, the OpenStack environment that we see here that allows us to do all of this, like to spin up and spin down and scale in and scale out as we want. Because of the centralized architecture of the DDoS solution, a new sensor is immediately effective. And if that wouldn't be the case, then what would be the point of adding it to the system? Meaning it comes up, it says hi to the centralized controller, and it will immediately get all the mitigation plans and information that it needs in order to help defending. Okay? And we built a little lab here based on OpenStack, and you see a lot of network management systems on the top, and you see two so-called SGVEs, which is the Allot Service Gateway Virtual Edition. And they are processing traffic when it comes in, and one of them is running. That's the SGVE1, and one of them is in shutdown in the moment because it's not needed. Okay? And when we switch over to our dashboard and our DDoS solution, this is like a dashboard for the NOC. We see that we are in peace, okay? And we see that we've seen some attacks in the past, but right now we're in peace. And I have the feeling that we're going to see an attack coming in soon, because that's what the demo is all about. Because I'm a little bit impatient, I usually do a refresh manually in order to see if something happened. Nothing happened yet. Also here we see that the device is still on shutdown. If I hit a refresh, oh, now it locked me out. That's very good. You can see it's live, and it's not recorded. Let's see if we're still in peace. Yes, we are. Where's our attacker? They're still sleeping.
Yeah, Houston. One moment. I'm running the attack command, and somehow I have a small glitch that is not running the attack.
Ariel is our attacker and our hacker. I wish for all of you that all the people that try to attack you are as effective as Ariel. But
let me do it again. Hang on.
Okay.
Okay. Give me one more second.
Yeah. The minute the attack starts, it's going to work within seconds that we're going to see that this is changing from peace to under attack. And at the same time, we're going to see that this standby SGVE is going to come up. You might ask yourself, why not leaving it running all the time? Because obviously the resources to run it are already there and are available. And the point is that in a virtualized environment, one of the big advantages is that when you have bare metal, every bare metal has to have the capacity for the extreme case. So meaning everything has to have a lot of headroom. And a lot of devices run on 10% or 20% CPU or even less. And in a virtualized environment...
if you can check also, meanwhile. If you can check while you're talking.
We're under attack. You actually share those headrooms and use it only when you need it. Okay, now we're under attack. And let's see what happens here. Let's hit the reload button.
I confess, I am attacking you.
Yes, and we can see that the SGVE started automatically and is now helping us to mitigate the attack traffic and keeping our network in peace. And I think Ariel, our attacker, sees that he doesn't really get through, and his attack doesn't have an effect, so he gives up. And we wait for the system to understand that there is a cooldown in the attack. Hitting the reload button. The site reloads by itself, but we don't have, you know, all the time of the world. So let's wait a little bit. And yeah, we're back in peace. This is still showing running. I hit the reload button here as well. And again, the device is suspending and is shut down in a second.
Wonderful.
Yeah, let's see it shut down. Now it's shut down. Wonderful, great. Thank you, Ariel, for being such a great hacker. I will stop sharing.
Yeah.
I hope you enjoyed the demo.
One more slide. We have one more slide to conclude, Michael.
Yeah, yes, we do. We have one more slide. So if we can return to the regular format, I will push a slide to the audience. And hopefully the slide is coming up for you now. Have you stopped sharing your screen?
I have stopped sharing my screen.
Yeah. So just to kind of summarize, I think that the main points that we talked about, and I want to add one point from one of the questions. Somebody asked about whether the inline system is using machine learning. So that is something that Elia did touch upon. And a nice anecdote, a true customer story. A couple of years ago, when there was the famous very large Memcache attack, which was, of course, a brand new attack, and as mentioned, nobody could be helped by threat intelligence systems because it was unknown at that point. We were curious after the fact, and we did some forensic investigation on some of our customers, and we discovered that in a number of locations, a number of carrier networks in Europe, we stopped the Memcache attack within seconds because we detected it as an anomalous traffic pattern that fit our criteria for what non-normal deviation from baseline benchmarking looks like, and that's exactly the strengths that we talked about of these inline machine learning zero-day mitigation. So there's that.
Great,
so
yeah.
DDoS Secure is.
To give the technical details about it, we take the traffic captures like a real PCAP, and that's a PCAP that we actually provide in the user interface for you to download afterwards in order to see for yourself what happened. And in that PCAP, we saw the Memcached port, and we saw the UDP protocol being used, and that was part of the pattern that we created in order to mitigate the attack. We didn't need to know in advance that this is Memcached. We didn't even know it's called Memcached. We just defended against it.
Thank you. Yeah, so DDoS Secure is all about detecting and mitigating these attacks inline without the prior knowledge of what they are. And NFV is all about the agility and the OPEX reduction and the ability to spin up added instances of whatever to deal with unforeseen changes in the demand and in the need, and in this case, in mitigation. Together, I hope you've, by yourselves drawn the same conclusion that with an NFV implementation, DDoS Secure is already basically 5G ready because it can be deployed inline across your entire network, and now it becomes much more cost effective because you don't have to worst case provision in every single location. You just need to have the headroom that Elia spoke about that can be used for all kinds of different on the fly operational scenarios. and be able to detect it. And it doesn't matter if it's outgoing or incoming. It's this bidirectional scalable solution that assures that the vital services continue to function at a high quality of experience level or at a low latency level at the mobile edge, solving this problem before it impacts your service delivery ability throughout the network. So it's on demand, it's network wide, and it gives you this 5G scalable protection to solve DDoS wherever and whenever and how big, however it happens in your network. So thank you all for joining us. Thank you, Ariel, and thank you, Elia, for your product expertise. I did my best to answer the Q&A questions as they came in. The ones that we didn't get to, I will try and take a look at on the next couple minutes if people want to hang on. But we will answer them offline as well. Again, if you want to send questions or requests for more information, there is that window. Please enter some details in the email so we'll understand what you want. There's a report which describes this presentation concept. It's at the link at the bottom of your screen. And the presentation is available, will be available shortly online, and you will get the slide deck as well. So thank you again. Keep us in mind if you're looking for a DDoS solution, and keep listening for upcoming webinars as well. Thank you very much, and have a good rest of the day and rest of the week.